All right, this is your instructional video for the specific heat lab, lab 4. Okay, so we're going to provide you with data that was collected by students in a previous semester, and you'll use that data as if it were your own to complete this activity. Okay, so let's talk about how this is going to go down and what you need to know. So for the first set of pre-lab questions, questions 1 through 3, these are all found in the background. Okay, page 43 of the lab manual. Okay, now notice question 3 here says values. Okay, so there are 2 answers here. Right? 2 different specific heats of water are given in the background, so you need to provide both answers. As for question 4, this is a simple matter of using your Google Foo to find this information. Okay, so simply Google specific heats of metals. Okay, and you'll find brass, gold, nickel, silver in your Google information. But you may have to do a conversion yourself to get the calories per gram. Okay, you're going to want to look for joules per gram degrees C in your Googled information, because you'll find all kinds of different units for specific heats of various metals, right? Look for the ones that say joules per gram, and then you may have to do your own conversion to get calories per gram, right? Remembering that 1 calorie is 4.184 joules. So you may have to do that conversion yourself, okay, to get that calories per gram, okay? So moving on, so question 6 is your first real calculation, and this is a Q equals ms delta T type of question, okay? You've got your mass is the 25 grams. You've got your delta T here, right? And then your specific heat, so this is S for water, okay, which you answered in question 3. Question 7 is another Q equals ms delta T question, right? This time you're going to use the specific heat of copper that you find in the background. Right? And then you're going to solve the equation for mass. Okay, so you're going to rearrange this equation to solve for the mass. Right, now question 8, you want to pay attention to the fact that delta T is T final minus T initial. Okay, so your T final is the 30.9. Your T initial is the 100. Right? Now remember that your specific heat of metal, that is going to be a positive value. Okay, so whatever answer you come up with, you're going to end up with a positive value. And just as a reminder, these questions all have the answers sitting over to the right. So you have to set up the calculation so that you get that correct answer. Okay? Now moving on to the actual data. Okay, so that's your pre-lab. So these values that I've written here in the data table, those are going to be provided for you. You'll find this in modules. Okay, if you don't write it down from this video, you can feel free to pause this video and write it down right now, or you can go to modules and there's a document for the specific heat sample data. Okay, you should enter this information in your manual. All right, write these numbers into the pages. I want to see them when I'm grading. Okay. So if you were in lab in person, you would test a piece of aluminum, you would test a piece of lead, and you would test a piece of zinc. Okay. Column A has the mass of the cool water, B is the mass of the metal itself, C is the temperature of the cool water, so that's your T initial, okay, for the water. Your temperature of the hot metal, that's your T initial for the metal. And then your final temperature for the water and the metal in the cup, that's your T final for both. Okay? So moving on to the actual calculation section. So you've got 3 sets of calculations to do. One set for each metal. Metal 1, metal 2, metal 3. So the aluminum is metal 1, lead is metal 2, and zinc is metal 3. Now, this is important. Okay, use joules for your heat calculations. Okay, if you try to use calories, your answers will be correct for calories, but is not what we're looking for. We specifically want you to use joules in your heat calculations here. Okay, now you can feel free to use your temperature changes, so your delta T's can be positive for everything. Okay, so delta T for your water is going to be E minus C, right? And that's going to be positive. For your metal, if I say E minus D for my metal, temperature final minus temperature initial, I'll get a negative value. But it's okay for the purposes of this activity to use positive values for all your temperature changes. So your delta T for your metal is going to be D minus E. Okay, that'll give you a positive value. Now your heat gained by the water, that is a Q equals MS delta T question. Okay, you have S of this is the specific heat of water, and you have that from the pre-lab. M you'll find right here in part A of your data. And so you can calculate Q for the water. Okay, be careful to watch your sig figs. Now for the metal, so finding specific heat of the metal in part I, you're going to take into account that Q of the water equals negative Q of the metal. But we are simply taking all of these as positive values, okay, because we're using a positive delta T for the metal. So you can simply take this as Q of the water that you found in part G equals Q of the metal, okay, and run your calculation simply that way, right? So Q of the metal is M of the metal, S of the metal, which you're going to find, and delta T for the metal. All right, so you're going to rearrange that, and you'll have S equals Q over M delta T. All right, and that's what you're doing in this part I. And you're going to do all of these calculations for all 3 of the metals. Right? Now, so that pretty much takes care of the lab activity itself. So let's move on to the post-lab questions. Right? So question number 1, this table here, okay, you're going to put in your values for metal 1, metal 2, and metal 3. Okay, so from your data table, this is part I, part M, and part Q. Okay, from your data table here. So I, M, and Q for each of your metals goes in this first column for specific heat experimental. Right, so your specific heat theoretical, this column comes from the background. Page 43, okay? Page 43 has a table of specific heats for various metals. So you're going to look up for the aluminum, the lead, and the zinc. and put those in this column. Okay, so you're looking for those theoretical backgrounds. This comes from the table on page 43. Right? Then you're going to plug those values into the percent error calculation here. Okay, so you're going to see how different the experimental values are from the theoretical, and you're going to get a percent error. All right, so moving on to our questions. So question 2, hopefully you'll be able to tell the difference. So compare the specific heat of water to the specific heats of the metals, and you should find that there's a pretty significant difference. So it can be a fairly simple answer, saying one is bigger than the other, that sort of thing. Okay. Question 3, we're going to ask how much heat is needed to raise the temperature of magnesium. So we're going to do a Q equals ms delta T problem, right? And you're going to use the S, the specific heat of the magnesium, again, from the background, page 43, right, to solve that problem. Question 4 is for water. It's another one of these, right? And you're going to rearrange to solve for T, right? And use the specific heat of water. Right? Question 5. So we're going to apply the idea that Q of the water equals negative Q of the metal. Right? So solve for Q of the water first. Okay? That will give you Q of the metal, and then you use this to find S of the metal. Okay, so first solve for Q of the water. You have all the information in the problem to find Q of the water. Then Q of the metal is just negative of that answer. Okay, and then you can use that to solve for S of the metal. All right, your bonus question is, I'm going to leave that for bonus, right? A little bit of a challenge question. And that pretty much does it. That's the end of our slides. Okay, so please feel free to ask me questions. Please make sure that you turn in pre-lab, lab, and post-lab when you submit your assignment. Remember, there's also a post-lab quiz for this because this is a lab. Okay, all the labs have a quiz in Canvas that needs to be completed. All right, have fun, and again, please ask me questions if you have difficulty.